Okay, so we finished this part up here. You should have finished this on your own here. Now we're going to look at classifying triangles in the coordinate plane. So we're going to find the measures of each side of the triangle, given the 3 points, and we're going to classify by its side. So the way this is saying is you have 3 points. So J is going to be -7, -7, so like down here somewhere. K is -9, 1, so like up here somewhere. And then L is -1, 1, so like over here somewhere. Okay? And that's just going to be the 3 points to connect to make the triangle. That's what it's going to look like. So in order to do this, we are actually going to determine the measures of each side. So we'll start with J, K. So from J to K, we have -7 and -7. K is -9, 1. Okay, so we're looking at this side right here. We're going to determine the length. So in order to determine the length, we're going to use the distance formula. So the distance formula, y2 minus y1 squared plus x2 minus x1 squared. Then we take the square root of the whole thing. Okay, so we're going to label them x1, y1, x2, y2. Okay, we're going to determine the distance. So first we're going to do y2 minus y1. y2 is 1 minus y1 is -7, so we'll do +7 squared plus parentheses x2, okay, is -9 minus x1 is -7, so we'll change that to a +7 since there's already a negative sign, squared. And honestly, for this, I just want you to type whatever's under this radical into a calculator. So do the 1 plus 7 squared plus -9 plus 7 squared, okay? And if you do that, you're going to put that answer into the radical, and you're going to get square root of 68, okay? So now we've done JK, we need to know the length between K and L. So we'll use K, -9, 1, and L, -1, -1. Okay, so now we have x1, y1, x2, y2. And again, we're going to use this distance formula. So, sorry, this is a really bad. Okay, so y2 minus y1. So y2 is -1 minus y1 is 1 squared plus x2 is -1 minus x1 is -9. So we'll switch the sign to a +9 squared. Again, type this -1 minus 1, so 2 squared, or -2 squared plus 8 squared into the calculator, and you're going to get, once again, 68. You're just going to put that under the square root sign. And lastly, we need to determine from J to L. So J is -7, sorry, and then L is -1, -1. So we'll have x1, y1, x2, y2. Distance here is going to be y2 minus y1, so +7, plus, keep the square, sorry, x2 is -1, minus -7 here again, so plus, okay, put the whole thing into the square root, and again, we're going to just type this part, -1 plus 7 squared, plus -1 plus 7 squared. Make sure you put the parentheses around them, put them in the calculator, okay? You're going to get 72 when you do that. So, we can see that from J to K is square root of 68, okay? From K to L is square root of 68, and this one is 72, square root of 72. So these two are the same. So if we have two sides the same, we know that it is isosceles. Okay? So if we have two sides the same, it's isosceles. If we have none of the sides the same, it's scalene. And if we have all three answers the same, then it is an equilateral triangle. Okay? So with this one, again, we're going to use J and K first. -3, 2, and 2, 6. Then we're going to use K and L. K is 2 and 6. L is 8, -1. And then we're going to use L and J. So J is -3, 2. And L is 8, -1. Okay, so again, x1, y1, x2, y2, x1, y1, x2, y2, x1, y1, x2, y2. Okay? So we're going to determine the distance for each of these. Okay? So y2 minus y1 is 6 minus 2 squared. x2 is 2 minus x1. So it's going to be plus 3 squared. Square root. Okay? Type whatever's underneath that radical, underneath the square root, into the calculator. You're going to get 41. Just put it underneath a square root. Okay? Again, y2 minus 1 minus y1 is 6 squared. x2 is 8 minus x1 is 2 squared. If we put a square root around it, we just type in whatever's underneath the square root in the calculator. We're going to get 85. And we're just going to put the square root over top of it. So you don't have to actually put the square root into the calculator. Okay? And again, y2 minus y1, negative 1, minus 2. x2 minus x1, 8, minus negative 3, so plus 3, squared. Put what's underneath the square root into the calculator. You'll get 130. Just put that in underneath the square root. Not any of those are the same. Okay? So since none of those three are the same, we are going to say that this is a scalene triangle, since this is the lengths of the sides. Okay? Now I want you to pause and do number 23. I'll go ahead and tell you. Do this. So 113, so J and K. x1, y1, x2, y2. Okay? Determine the distance for that one. K and L, 3, 3. 10, negative 6. Okay, so x1, y1, x2, y2. Determine the distance for that one. And then J and L, 1, negative 13, 10, negative 6. Okay, x1, y1, x2, y2. And you can determine the distance for that one. Okay, so pause the video right now and go ahead and try to figure out what your answers are whenever you do this on your own. Okay, so these are the answers you should have got. You should have got square root of 260, square root of 130, and square root of 130. You can see that these two are the same, since it's got, looks like this, probably something like this, maybe twisted around a little bit. These are the lengths. You see that two of them are the same, so it's an isosceles triangle. Now I want you to try number 24 on your own. Again, do J and K, K and L, okay, and then J and L. Figure out what the distance is for each of those and determine whether none of them are the same, two of them are the same, or all three of them are the same, and label it based on that. So I'm going to let you go. You go try that one on your own. Let me know if you have any issues, and I will see you guys later.